on the spanning tree protocol. Okay, so let me use one of the PPT. Let me open that. So we'll discuss the spanning tree protocol, then we'll do the lab and all. So okay, so we have to understand what is the spanning tree protocol. So spanning tree protocol is the protocol which is going to help to provide the layer 2 topology as a loop free. As I mentioned that in previous sections, there is a chance you're going to make a loop. Always you're going to make a loop. So how you can avoid that? How we can avoid that? So that is a spanning tree protocol is going to there. And this spanning tree protocol is enable switch to become aware which port should be in blocking stage and which should be the forwarding state to avoid the loop. And they have the multiple method to do that. Means multiple protocol with common spanning tree. Very the old one. We have the RSTP, we have the PBST plus, right? So there are different kind of the protocols. So we have to understand all the protocols, why we need this protocol and that protocol. That definitely will understand those things. So if I talk about further, STP is basically one of the standard of the IEEE 802.1d, and it is going to logically prevent the loop, right? It is going to create a loop-free topology, and it is going to block your redundant link, but keep them as a backup. Means whenever any kind of the loop is going to be happen, it will automatically, this protocol is automatically going to block that loop, and it is going to allow one port as a active port, that is a forwarding port, rest is going to block. But in case of my block port is going to be down, it will automatically enable the backup port, so that this is going to be start following the traffic. So there is zero loop is going to happen, automatic fail recovery is going to happen, that all due to the STP feature. And why do you need STP? Based, if we are not going to use STP, what is going to happen is packet is going to be sent from this PC to this PC. Might be the same packet is going to be returned back and it's going to make a loop. You can see here. So due to this loop, your processor of CPU is going to be high. Your switches, router, processor is going to be high, and there is a might be a chance their switches are going to be crash. So all packets are going to be loop. So switch forward the broadcast, unknown unicast frame, redundant link cows, broadcast storm, MAC table instability, multiple frame copies, and TTL value, no TTL value, loop are dangerous. STP prevent the loop, blocking the redundant path. So if you are not going to use a loop, then there are a lot of possibility your switch is going to be crash, your VLAN is going to be crash, your device is, means you cannot make any communication. So that's why you always going to create the your STP to avoid the loop. And how it is going to happen? Let's suppose I want to configure the STP. So different ports have a different roles. Different switch having a different role. So you can see here in this topology, these two ports are in forwarding state. Means they are forwarding the traffic. This is also forwarding the traffic, but this port in the blocking state. But how the calculation was happen? That also we have to understand what is the logic behind it and how they basically going to be, block that port, allow that port. That also we have to understand. So there are a lot of concept, right? The very first concept, guys, the bridge ID. You can see here this mentioned as the bridge ID. So what is a bridge ID? Bridge ID is basically every switch having their two component, their MAC address and their priority. So bridge ID is basically combination of these two things. Means any switch you want to put in the spanning tree group, they will calculate their bridge ID. And this bridge ID based on their MAC address and the priority. Default priority of the every switch. Any new switch you are configuring, if you go and check the default priority, it is going to 32768. Let me show you. If I'm going on the switch 1, show a spanning tree VLAN 1. So this is the 32769, right? 68, but one is going to be added when the priority is going to be calculated. One is by default, it's going to be added. So whenever any switch is coming, any kind of the calculation, by default, they're going to add their link cost in this priority. So if you go here and check default priority of switch is 3 to what is the value? 32768. You'll get the answer, means how it is going to be. So they're going to default VLAN always Cisco switches. So default is this one, VLAN ID is 1. So they always going to add whatever the VLAN ID with this priority. So it is going to become your 369. So if any VLAN ID is 10, for that priority is going to be added like this. Any VLAN ID 100. So based on the VLANs they are going to add. So I check that command for the VLAN 1. That's why you can see this is the priority. But default priority is going to be your 32768 only. And what are the VLAN number you're going to add it? They are going to just add that VLAN number. That's why your priority is going to be like this one. Clear? So don't be confused why this priority is like this. So any switch which is going to part of the STP domain, there is a bridge ID. So this switch having a different bridge ID, this switch having a different bridge ID, this having a different bridge ID. So if priority is all same, then how they are going to be identify uniqueness, which switch having a what bridge ID. So the tiebreaker is going to happen the MAC address. Every switch having their different MAC address. You can see every VLAN, every switch having a different MAC address. This cannot be same for the all switch. If I'm checking for the my switch 1, this is my MAC address. But if I'm going to check on the switch 2, show the spanning tree, VLAN 1. See, this MAC address is totally different. 5000 This is the 5000 Okay, this is showing the root ID. Sorry, this is the bridge ID. You can just focus on this one. Bridge ID, this one, and this one. This bridge ID is your unique MAC address. Root ID is basically it's showing the root switch MAC address. Who is my root switch? But bridge, you just focus on the bridge ID. Bridge ID is 32768, right? And this you can see priority is by default this one, and system ID extension 1. This is my 5000 and 000. But this switch having the different bridge ID. It cannot be same. If you go to the switch 3, show spanning tree VLAN 1, you are going to find this is the 3 VLAN ID. Clear? So this is always going to be considered as a different and default is given this one. And in this switch, who is going to select my bridge, root bridge? There is selection of the root bridge. So root bridge is going to selected the switch which having a lower bridge ID. If I want to select the root bridge, means why root bridge is important? Because the root bridge is going to be maintain all kind of responsibility, topology notifications, anything is changing in that my topology, that is going to be responsibility of the root bridge. So you can just, what is the role of the root bridge? You can just search it. You're going to find the role of root bridge means any topology notification, any kind of the broadcasting is going to happen. Means loop prevention, BPD generations, timer management, topology change handling. This everything is going to be means I'm the boss. I will handle everything regarding the means logical anchor. Logical anchor means it is going to be boss for the topology. Definitely loop prevention is going to happen, but BPD is one of the bridge protocol data init. This is a layer 2 protocol. This layer 2 protocol is going to carry a lot of informations. Any topology change is going to happen. So this VP2 is going to report to my root switch, means root bridge, and this is going to further maintain the topology and change it. So the bridge ID is basically always going to calculate the lower switch port, means whatever the lower switch port will have, that is going to become my root bridge. Now, once you select the root bridge, you have to select in this switch which port is going to be my forwarding port and which port is going to be blocking port. So there are a lot of ports available. You can see here, we have the designated port. This is a port role, designated port, root port, and block port. So why these three ports are going to be required? Block means this is definitely not going to forward traffic. But what is the designated port and what is the root port? Okay, so let's understand in the layman language. First of all, what is a designated port? Designated port, any LAN segment. Okay, say this is my LAN segment. I have two ports. In very layman language, how you identify that? You just divide it and try to say which port is close to my root bridge. Which one is close to my root bridge? This one is close to my root bridge. So this will become my designated port. For this one also, in this LAN segment, which one is close to my root bridge? This one. So it will become my root port. So by default, any means first understanding the root bridge. Root bridge is going to be selected based on the lower priority or MAC address. Let's suppose this switch having a MAC address AAA, this having the BBBBB, this is a CCCCC. Priority is same. So who is going to become my root bridge? This switch. By default, this switch, all port are going to be designated port. Or you just try to divide the link and try to check from this port of point which path is closer to my root bridge. This port is closer. So this is going to be my root bridge. But by default, you can think any port from the root bridge, it's going to be designated port only. Now, in front of designated port, that port is always going to be a root port. Because not always, but in this LAN segment, in this case, in this LAN segment, always going to be root port. Why? For this LAN segment point of view, this switch point of view, think which path is closest to reach my root bridge. There is one path, this one, another path, this one. This path is longer, but how the longest calculation has been happened? What is the method to calculate the longer calculations? I will explain that also. But think on logical point of view, topology point of view, this path is more closer, so this will become my root bridge. Only two paths to reach send the traffic to my root bridge. This path and this path. But this path is quite long, so this is become my root bridge. Now think about this switch point of view. There is again two paths. One is this one and one is this one. But this path is closer, so this will become my root bridge. I hope it is clear, right? How I am doing that. Think about designated port clear. Everyone, how calculated from the root bridge. I will discuss more about that. But for time being, you guys understand 𝗵𝗵𝗃 Sikandar battalion. It's clear, right? I'm just thinking you guys understand. Okay, nobody's speaking. So
Switch to the designated port, how it become designated port. But switch to.
No, switch to. I'm just talking about right now root port. Root port, how we calculated? You understand? From
Okay.
this switch, I have two paths. I can reach from this to this. I can reach from this to this. Right? Which one is the closest? This one or this one? This one, right?
Yes.
So this will become my root. From this switch point of view, this one is my closest. This one is longest. This will going to become my root port. Now, problem is going to happen from this point of view. Now, from this switch point of view, we have to think which port is going to be my designated port, right? In one switch, only one port is going to be root port. It's very much clear. One switch, only one port is going to be root switch, but you have the multiple designated port. So if I just divide this link, I have the equal cost to reach this switch also in my root bridge, and this is also going to be equally reached to there. So this also eligible for designated port, this also eligible for designated port. We agree? In both case, this also eligible for designated port, this also eligible for designated port. But which one is going to be selected designated port? So this is going to happen based on the neighbor bridge ID. So this MAC address is BBB, this MAC address is CCC. So which one is lower? Priority is same. Priority is same. So which one is lower? This one is going to be lower and this one is the higher because this priority is going to be higher. So this is going to be designated port, and in front of the port designated is going to be blocking port. It's never going to become my root port. On switch only one root port. So it's going to be blocking port. So this is the high level, but let's understand the low level, how the cost is going to be calculated on all. So if I go there, you can see here lower priority. You have the MAC address. You have the this priority, this priority, this priority. So in this switch, can you just someone tell me which one is going to be my root bridge? Which one is going to be my root bridge? A, B, C, D, E, F, A, B, C, D, E. Which switch is going to become my root bridge? Any guess?
Switch 1A.
Okay, so Dinesh saying switch 1A. What others, guys? Which one is going to my root bridge and why? Come on, guys, think about it a little bit.
Yeah, switch A is going to become a root bridge because it is having a low priority and low MAC address.
This one also having low priority.
But the MAC address is the smallest one for switch A.
So this is going to my
Root bridge.
Root bridge.
Okay. So this is going to my root bridge. Now, what is the role of this ports? This and this port. DP or RP?
Designated.
Sorry?
Designated DP.
DP. Okay. This is going to be DP. Now think about this switch point of view. Just in very high level, just think about all link speed is same. 1 Gbps speed we have, all link. Now this switch point of view, you tell me this port role, what is going to happen?
Since it is in front of the root bridge, it will become the root port.
Why root port? Because if from this switch point of view, reaching this switch, the cost is lower. But if you another path, this one, it's a longer path. Okay.
Yes.
The calculation is the cost is same, means 1 or the 1 Gbps speed, right? So if I'm going via this path, it is going to be cost is higher. I will tell how the cost is going to be calculated. But let me explain first cost somewhere in the, so how the cost is going to be calculated. Let me tell, see, this is the cost calculations. If now just focus on this link. So if all are the 1 Gbps link, so the cost is going to be 1 Gbps link is a 4. If you have a 10 Gbps, this is a 2. If you have the 4 Mbps, this is a 250 cost. So if I want to select the root bridge, this one, so this is my going to be DP. This is also my DP. But from this switch point of view, you think if I'm going from this path to how many cost is going to happen? 4, 4, 4, and 4, 16. But here it's a lower. So it's going to my RP. Clear? Is it clear to everyone how the cost is calculated?
Yes, sir.
And from this switch point also, if you go from there, the cost is going to 4. But if you go from this way, it's going to be 16. So this is going to be your RP. Now, think about this switch point of view. This switch of point of view, this first let's calculate all RP, then we configure the DP. This LAN segment point of view, first think about this LAN segment. Which port is closest to reach to the root bridge from this LAN segment? This port or this port? This port or this port from this LAN segment?
Up one.
Up one. So this is going to become my DP. This is also going to become my DP. And definitely if I go here, if I reaching from this way to, from this switch point of view, now always DP is going to calculate based on the LAN segment and RP is going to calculate based on your cost. So if I'm going via this path, so cost is going to be 12. And from this path, it is going to be my, how much code? 8. So it's going to my RP. Clear? This is also going to my RP. Now you tell me from this LAN segment point of view, which path is lower to reach my root bridge from this LAN point of view to calculate a DP? Any guess? Both are same.
Yes. But we don't know the MAC, sir. Lowest MAC if we can find for switch D
So
and
if
switch
both are same, then tiebreaker happen based on the bridge ID. So MAC address, just think about this is a D MAC address, this is a E MAC address. Then what is going to happen in that case?
D will be designated and that E will be blocking.
Yes. So always in front of designated, if there is no one switch having the only one RP, already RP calculated, so it's going to be blocking. Means one switch, only one RP, not two RP. You can see no switch have a dual RP. So it's going to blocking stage. Why? To avoid the loop. So the cost is going to be this way. Now let me give one different topology, or let me use the same one. Let me try to, okay, let me go here. This is my switch 1, switch 2, right? Switch 3, switch 4, switch 5. Now, this link is my Ethernet. This is also Ethernet, but this is my gig, and gig. Consider this is a MAC address A, B, C, D, E. All have the same priority, right? So which one is going to become my root bridge? Can someone tell me? MAC address A, B, C, D, E, and priority is same. Which one is going to make a root bridge?
A will become
sir.
the root bridge.
Switch 1, A.
Okay, this is my root bridge. And what is the port of this one?
DP, DP.
DP and DP. Now, for this switch of point of view, what is my RP port? Let me put this value here in front of you. See, Ethernet cost is going to be your 100 is Ethernet, right? So fast Ethernet, let's consider the 100, cost is 100 and GPS is 4, okay? So you always refer this one, okay? So I mentioned that this thing was, this is the fast Ethernet port, not Ethernet. It's the fast Ethernet. This is also fast Ethernet. So this link cost is 100, this is 100, this is 4, this is 4, this is 4. So now tell me from this switch of point of view, what is my RP port? Switch point of view, just tell me. What is my RP port? If I reach from this link, how many costs is going to happen? 100? Make sense?
Yes.
If I reach from this one, then it is going to be 100, 444, 112, right? So this is going to be RP. Clear? Now tell me from this LAN segment point of view, which is my closest part to reach my root? This one or this one? Definitely this one, right? Because it's 100, right? If you calculate, like here you take it from this LAN point of view, LAN segment point of view. So this is going to be 50, 150. So logically it is going to be, it's going to be your, this one is going to be your DP port, and this is always going to be your blocking port, right? As per the calculation. Now you think about this one, this switch point of view. So this is going to be your RP port, okay? Why RP? Because there is a 200 cost and here is the 16 cost. Make sense? So this is going to be RP. Now from this LAN point of view, it's going to be, if you go from this side, it is going to be your higher cost. This is a lower cost. So DP. Now from this switch point of view, it is going to be your RP port because it's going to be lower, and this is going to be your LAN segment. This is going to be your DP port, and this is going to be your RP port. This is going to be your DP port. So blocking port is going to happen this one. Make sense? How it is going to be calculated? So blocking, not this one is going to happen. This one is going to be your blocking port. So always you have to calculate based on the cost. Always think what is the cost to reach from the each LAN segment to for my root bridge. That is going to be your DP calculation from root switch, means your switch point of view. Just trying to think about your how to reach my any kind of the root bridge. So this you should know about in this calculation. So same thing they are talking about. If anything tiebreaker is going to happen, so in that case, you always have to consider lowest upstream bridge priority. So in that case, upstream bridge priority is this one. So you can just think in this way. Let's suppose I have this topology. Switch 1, and this is going to be switch 2. Now this MAC address is AAA. This is the BBBBB, right? 32768. 32768. Which is my root switch? Can someone tell me?
Switch 1.
Okay, this is my root. Okay. Now tell me what is the port of role this one?
Designated port.
DP. DP. Now tell me what is the port of this role? This and this. For this switcher point of view, only one port is going to become my what port? That is the
RP.
So which one is going to become? This one or this one? Because their priority is same. If you just consider with the neighbor, there is no neighbor. So my priority is same for both of the case. Means my switch priority is same. Bridge ID is same for the both port. Then how it is going to calculate it?
How about the cost, sir?
Yes, the port cost. So whatever the port cost is lower, it is going to become my
RP.
If the port cost is same, then port ID, lower port ID is going to become my RP. So let's suppose this is my 0/2, 0/3. So this is going to become my RP, and this is going to be blocking state. So clear all scenario. In case of you don't have the neighbor bridge ID to just tiebreaker calculation. So you just have to use the port cost. If port cost is same, then you can just use your port ID. So you go here and check it. What if my port cost same for RP calculation? So this is going to be considered what happened lowest bridge ID, sender port ID. So if in this case, it's going to sender port ID. So the lower number is going to preferred if cost is going to be same. Either your lowest MAC address. So always consider this all calculations, guys. Okay, I hope it is clear to everyone and you're good till here. So this is how you can configure. Designated port is going to be you can just read about it. Every cable STP allow one switch port to forwarding port. The switch port that has the best part to reach the read. So always calculate from the LAN segment point of view. That is become my designated port. Port ID is going to be like in case of tiebreaker, port priority is going to be there by default 128, but port priority is going to be same. Not port cost, that is a port priority. Then it is going to tiebreaker is going to be interface number. So that is going to be my tiebreaker. And now if we talk about the STP states, so STP is going to be use the multiple states. By default, STP is going to run as a blocking, listening, learning, forwarding, disable state. And in case of that, it's going to take a 50 second to do the conversions. Normal STP, we are going to talk about that. So to avoid these situations, we do not use a normal step. If you go and run the command, show run include spanning tree. Right now, this is running the PBST. You can run even it's not a per VLAN spanning tree protocol. You can change that PBS2 as a RSTP as well. So by default, you are not going to find any STPs learning, means running on your switches or routers. No, you're not going to find that. Why? Because it's a very slow protocols, and slow protocols are going to be give the slow convergence in network. So that is not recommended, guys. But for the learning point of view, you should know about that. They have the 5 state: disable, blocking, listening, learning, and forwarding. So by default, when port is disables, there is no step is running. blocking means it's a block and it is going to be act as an alternate path. Means let's suppose in this topology, for some reason, if this switch is going to be down, this port is going to be down for some reason. This side port is going to be down. So this blocking port for this switch point of view, this become a forwarding port. So your traffic is going to start via this way. If this port is going to be lost, this particular link has been disconnected. So you cannot make the loop now. So this leg has been disconnected. So you can just send via this one to make the traffic. So this your blocking port, whatever the blocking port, this one is going to become my forwarding port. So it's going to act as an alternate forwarding port in case of the anything failure is going to happen in the my switching infrastructures. Clear? Listening is basically if somebody is sending the BPDU, I'm going to listen and I'll wait for 15 seconds. And then learning means the port role has been determined whether I'm going to become my designated port, my root port, or might be the blocking port. And then it is going to the forwarding state. So even you're going to run this command, show spanning tree VLAN1, you see by default all ports are showing the forwarding port. All because this is my root bridge. How to check the root bridge? Because for VLAN1, the priority is this one, and this is my root bridge. So this switch where I'm sitting right now, it's a root bridge. So by default, you can see all ports are in the designated port. But if I go on my switch 4 or switch 5, let me go there, switch 4. You're not going to find all port as a designated port. So spanning tree VLAN1. You see, this is not my root bridge. See, this is not my root bridge. It's not mentioned here. And you can see some port are root port, some port are designated port. But in the switch 1, all port are designated port. But let me check where is the blocking port. So if I go in the, switch 5 as well. Show spanning tree VLAN1. Here you can see there is an alternate port, that is the blocking port available. So it's automatically calculated. I haven't done anything. So whenever you enable the STP, you don't have to use any brain to do the like which one is going to be alternate blocking. It will do automatically. Spanning tree have the intelligence. The moment you're going to enable, it will do automatically for you, and they will calculate the port role. Now, the STP timers are hello timers 2 seconds, power delay 15 seconds, max is 20 seconds. And the cost, we know that faster than 19 gigabit is going to 4, and lowest path cost is going to be always preferred. Now, when we talk about the STP having the multiple type. We have the STP, that is the old protocol 802.1d, original and slow. But we have the RSTP, that the standard is 802.1w. This was the new standard they have developed, and that is a very faster convergence. So this is the different we have the method. Now we have this PBST. PBST is always per VLAN spanning tree that is running on the switch as well. This is my Cisco proprietary protocol. So it's run in the only Cisco, but this can be run in the Juniper, any kind of the Huawei switch, any kind of the Nokia switch. RSTP also, again, the rapid PBST is also for the Cisco. MST is also for the Cisco. These are all the Cisco. Multiple VLAN map into the instance, that is the MSTP. Means if you want to map the multiple VLANs together, that is going to be used as the MSTP. So I will show you, but these are the different protocols we have, and these can be used in our configuration. So even you can see, we have to configure the RSTP and MST. So I will show you how it is going to happen just after this theory session. Now, if you want to learn more about that, there is the spanning tree, then one STP instance is going to run for the all VLANs. Per VLAN spanning tree is going to be run if you're going to run the PBST. Means every VLAN, they have the individual instance. So by default, Cisco support this one. MSTP support multiple VLAN. Means if you have the 100 VLAN, you want to run one instance for the 100 VLAN, it is going to create it in the MSTP. But STP, if you have thousands VLAN, you cannot bifurcate. By default, if you're going to run the STP, all VLAN on the switch is going to be part of the same instance, and that's going to be very problem. Means only one switch is going to have all load, and it's a very slow convergence. But for VLAN, it's going to VLAN base like what I can say. Segregations means every VLAN could have a different switch, root bridge, and the forwarding methods. And RSTP differently, it's a very fast, and the modern requirement is going to be used in this RSTP. MSTP is going to be multiple VLAN. RSTP is very fast. It's let me show you even RSTP timers and all. So if you go and see the timers, so they use the uplink fast, port fast, backbone fast. So I will discuss this whole thing, but let me show the timers. I will do the all configuration. See here. So I want to show the RSTP. So if you go with RSTP is basically rapid ascending protocol. The timer are very fast. Traditional, it's going to take 30 to 50 seconds. Listening, learning instead due to listening, learning, but in this, just you go listen, learn, and forwarding state. It's going to be very fast. So you can see. Let me STP versus RSTP states. It's available in slides also, but I want to show you. So you can see learning and forwarding. It is just going to bypass your disabling, blocking, listening. So it's going to be direct learn. Its port is going to discarding, learning, and forwarding. So going to very fast. Immediate your packet is going to be forwarded in case of your RSTP. And the port role is going to be alternate port, backup port. So this also you're going to find it here. In RSTP, you're going to get a port as a root port, alternate port, designated port, backup port. This is the RSTP port roles. So alternate port, backup port, there is going to be again root port, and designated port definitely going to be there. Backup port is going to act as a designated backup port. You're not going to find that. Alternate port is going to be like root port backup. In case of any failure is going to happen, it is going to be always going to be available. So root port again, best part to reach to my root bridge, designated port, best part of the network segment, LAN segment. What is the best part to reach my root bridge to forward the traffic? Backup part is going to always give the backup port is the port backup for the your any kind of the designated port. Alternate port is going to be part of the your RP. In case of any RP failure, it's immediately available to make the decisions to forward the traffic. So this is a port role is going to be happen. And you can see the purpose, best path to reach, backup path, forwarding segments, backup path is going to be backup of designated. And these are the state. I was just searching that. So only discarding, learning, listening, forwarding state we have available. But in STP, we have the multiple state, right? So now let me little bit go here because we understand good way. So now if I want to enable the RSTP on the switch, how I can enable the RSTP on the switch? So by default, it's a PBST. Usually that PBST has been enabled, but you want to enable the RSTP, then there is a command. You go on the switches. You go here and spanning tree, you run that. What spanning tree want to use? So spanning tree mode, I want to use that as a rapid spanning tree protocol. Don't use the PBST MST. MST will do that. So you just this command, this one. That's all. So I'm going to put this all command on the all switches. This is done. This is done. This is done. So now let's show you all 5 switches. I have done this all configuration. So if I'm running here, show spanning tree, you see my only one VLAN is there. And for that VLAN, even my all port are showing a designated port, all port and designated port. Even in the switch to show spanning tree, you will see all port are designated except one port, the root port. Which port is the root port? You see, I'm in the 2-number switch. By default, 2-number switch, which port should be a root port? This one, 0 by 0, and showing the 0 by 0 as a root port. See here, it's showing the 0 by 0 as a root port. Clear? By default, other are designated port. If I'm going the switch 3, so if I run here, show spanning tree, you see there is a which port should be 0 by 1 should be root port, and see 0 by 1 is a already root port. Our calculation is fine. Now on the switch 4, this should be root port, this is designated port. So let me check on this. So there's an alternate and backup port also going to come in a picture. So show a spanning tree and see these are the root port. 0 by 2 is a root port. Yeah, that's correct. Root port, rest are designated ports. It's also correct. Now last switch is my switch 5. So spanning tree, and you'll see there is no blocking port. It's showing the alternate port. Alternate port by default is going to be blocking port. Means role is alternate port. But in case of any failure is going to happen, it is going to be forwarded traffic. So this is my 0 by 0. So you guys see how we can enable this spanning tree and how we can check that. Most important. Very first command, when you run the spanning tree, you clearly see this is my root bridge, right? But on switch 2, if you're running the same command, showing that cost to reach to my root bridge is 4. You can see cost to reach from this switch is the 4, right? This is the cost because there's 1 gig ports, by default is going to 4 only. But very important, see this one, port. What is this meaning? This meaning is from this port you can reach to my root switch. If you want to reach my root bridge, if you want to reach my root switch, this is my root, but this is clearly showing I'm the root. But from this switcher point, if I want to reach the root, which is my best path? This path or this path? This is going to tell this path you go via the root. So whatever your root port is going to be there, it's going to be always available here as a best path. See, this is so it's my uplink to go on my root switch. If you go by the switch 3, 0 by 1 is my uplink to go my root switch. This is this one. If you have 4 point of view, you can see here. So it's my 0 by 2. This is my best path to go to my there. If I'm going the 5, it is going to my 0 by 3. So you can see here, right? Any doubt, guys, still here? Anyone? I believe you're good with the STP. All clear with the STP? Shall I go and explain that MSTP? Then we'll discuss about the root guard and PPT guard as well. Okay. Let me stop this recording. Give me 1 second.